April 6, 1945. Off Okinawa, in the East China Sea, dawn light spills over task. Force 58 of the U.S. Fifth Fleet. On radar picket destroyers. Sitting about 16 miles from the main formation, crews sweep the skyline, braced for what's coming. Inside USS Lee's Combat Information Center, radar men pick up contact after contact. Not just a few, but scores and scores, while the ship's 5-inch gun crews ram in shells stamped with VT markings, each housing a tiny radio transmitter that would change naval combat forever. The mission was simple and grim. Survive the first of 10 massive coordinated kamikaze strikes. Operation Kikasui no On. At 0600, the air-filled, through the morning haze rose a sound that would come to define Okinawa with a steady roar of hundreds of Japanese engines arriving in waves. Pilots sealed in cockpits with no plan to come back. Leading the charge were the Imperial Japanese Navy's Special Attack Flyers, Mitsubishi, A6M0s, and Yokosu D4Y, dive bombers loaded with 250 kilograms bombs, followed by older planes pressed into suicide duty. Mixed among them were crews piloting rocket-powered human-guided bombs known as Oka, ferried into range by Mitsubishi G4M Betty Mother planes. What followed would expose how profoundly the American proximity fuse altered anti-aircraft warfare and explain why the kamikaze barrage, so lethal at first, eventually faltered against the most advanced air defense system then fielded. Asterisk. The VT proximity fuse had only recently reached the Pacific after 2 years of combat trials that traced back to a single decisive firing. It was the product of a crash development effort begun in 1940 by Section T of Johns Hopkins Applied Physics Laboratory under Dr. Merle Tuve, and was counted among the 3 top-secret projects of the war, alongside radar and the atomic bomb. The device worked on a cleverly simple idea. A compact radio transmitter receiver continuously emitted radio waves and listened for their return. When the Doppler shift signaled the projectile was closing on a target, the fuse triggered the shell to explode automatically. Gunners no longer had to guess range and set mechanical timers. The munition decided the moment of detonation itself. Asterisk. Achieving that simplicity demanded enormous technical leaps. The fuse's parts, including minute glass vacuum tubes made by Slovenia, had to survive launch accelerations up to 20,000 times gravity when fired from a 5-inch gun. The projectile shot out at roughly 2,600 feet per second while spinning at about 25,000 revolutions per minute through the barrel's rifling. Every element had to survive that violent ejection and then operate reliably across temperatures from +100 to 50 Fahrenheit. By April 1945, American industry had turned out more than 15 million proximity fuses for naval use in the Pacific, with production spread among many contractors. Crossley alone manufactured 525,913 fuses, about 24% of one measured batch, while RCA, Eastman, Kodak, General Electric, Mechanarus, and some 87 other firms across roughly 110 factories handled different stages of the work. That industrial scale meant the ships at Okinawa carried the most advanced anti-aircraft ammunition ever made. Asterisk. The Navy ramped up how many VT rounds it issued from roughly a quarter of anti-aircraft ammunition in 1943 to about 3/4 by 1945 because fighting kamikazes in the Pacific demanded a radical new defense. Destroyers, cruisers, and battleships all carried thousands of VTI-fused 5-inch shells as their primary shield against suicide strikes. Japan's kamikaze program, by contrast, had arisen out of desperation. After crushing losses in the Marianas and the Battle of the Philippine Sea had wiped out most veteran aircrews and carriers, Vice Admiral Takejiro Nishi proposed forming special attack units in October 1944, arguing that ordinary tactics could not overcome overwhelming American firepower. The kamikaze was an attempt to turn the remaining, inexperienced pilots into one-way guided weapons. On paper, it looked effective. Conventional dive or level attacks scored hits only around 2% against well-defended U.S. ships, while early kamikaze raids in the Philippines posted success rates reportedly above 34%. One pilot in a Zero with a 250 kilograms bomb could trade a single life and an obsolescent aircraft for sinking or crippling a destroyer, inflicting dozens or hundreds of casualties and causing millions of dollars in damage. Asterisks. Training for these missions was brief and tilted toward ritual rather than advanced flying. Many volunteers had under 100 hours of flight time compared with the 500-plus hours flown by earlier generations of Japanese aviators. Instruction focused on basic navigation, ship recognition, and, most crucially, the final diving run meant to evade or saturate anti-aircraft fire. Pilots wrote farewell letters, took ceremonial sake toasts, and were given symbolic items, samurai blades, or rising sun headbands before launch. But spiritual resolve could not compensate for the technological revolution they were about to meet. Asterisk. The piloted Oka embodied the kamikaze idea taken to its extreme, nicknamed Baka Fool by American sailors. The device was a manned rocket bomb carrying a roughly 1,200-kilogram warhead and propelled by 3 solid-fuel rockets. In a terminal dive, it could reach about 575 miles per hour and was intended to be unstoppable once released. Its critical flaw, however, was its tiny range, barely 10 miles, forcing vulnerable bombers to haul them well within reach of U.S. defenses. The difference in defensive doctrine was stark. American ships arranged concentric layers of protection, with radar picket destroyers placed outboard to give early warning and to take the first blows. Each picket might field a dozen to 16 5-inch guns able to fire VT rounds, so their arcs overlapped. The proximity fuse turned those guns from crude area denial weapons into far more precise killers. A 5-inch VT shell had an effective lethal radius of roughly 70 feet versus about 20 feet for a comparable time-fused round. And because the fuse removed the need for elaborate range calculations, crews could open fire the instant a target was detected. April 6, 1945, would prove the concept under the harshest conditions. Operation Kikasui No. 1 marshaled 391 Navy aircraft and 133 Army aircraft, of which 215 Navy and 82 Army planes were committed as kamikazes, a total of 297 suicide aircraft in a single coordinated onslaught. Commander Frederick Julian Becker of U.S. Laffey later likened the incoming waves to a swarm of bees, headed straight for the only flower in a desert. 600 The first strike hit as radar crews picked up more than 50 planes coming in from the north. The picket destroyers immediately opened up at roughly 12,000 yards, with 5-inch rounds fitted with VT proximity fuses. Those fuses proved ruthlessly effective. Any shell that passed within lethal distance detonated on its own, turning near misses into kills and filling the air with shrapnel. Within minutes, dozens of Japanese aircraft were plunging into the sea, though more kamikazes kept arriving. At 0744 USS Laffey endured a concentrated assault of 22 planes over an 80-minute span. Her gunners expended 345 5-inch VT rounds and shot down 9 attackers. The proximity fuses let Laffey's crews engage multiple targets at once, switching targets rapidly without pauses to set mechanical fuses. When pilots tried low wavetop approaches to evade radar, the VT rounds were just as lethal, detonating near the sea surface and creating curtains of fragments that shredded aircraft flying very low. Despite that punishing defensive fire, Laffey was struck by 6 kamikazes and 4 bombs and yet survived. Testimony both to American damage control and to the many attackers the fuses had stopped. The fuse's power was not accidental. It had been combat proven as early as January 5, 1943, when USS Helena fired the first proximity fused rounds off Guadalcanal. Lieutenant Red Cochran, commanding the aft 5-inch battery, brought down a Japanese D-3 Naval dive bomber with the second of 3 salvos. Even though none of the shells made direct contact, their near detonations shredded the aircraft with fragments. That one success vindicated 3 years of relentless development that had solved immense engineering problems. The device squeezed roughly 130 electronic parts into a space smaller than a pint bottle and was manufactured to tolerances measured in thousandths of an inch. By the Okinawa fighting, the numbers made the advantage clear. Time-fused 5-inch shells averaged about 1,162 rounds to destroy a single kamikaze, while VT-fused rounds cut that requirement to roughly 310 rounds per kill, nearly a 4-fold improvement. In the best circumstances, the gains were even more striking. The destroyer escort USS Abercrombie downed a kamikaze with only 2 VT rounds in May 1945, and USS Morrison shot down 8 attackers in minutes with proximity-fused ammunition on May 4th, before overwhelming numbers prevailed. The effect extended beyond statistics. Survivors who aborted their missions reported flying into what felt like a solid wall of bursting shells. The black puffs of VT detonations appeared with uncanny precision, as if American gunners could see exactly where each plane would be. Japanese doctrine that favored high-speed low-altitude runs to minimize exposure was effectively undone. Shells that would once have missed by 50 feet now exploded at lethal closeness, turning the final approach into a deadly gauntlet. Vice Admiral Marty Ugaki, directing special attack operations from Kyushu, recorded the mounting devastation of American AA fire. By late April 1945, Japanese naval intelligence estimated fewer than 1 in 4 kamikaze aircraft were reaching their targets, down from about 1 in 3 during the Philippines campaign, and attributed the decline largely to a new kind of anti-aircraft shell that burst with seemingly impossible accuracy. Individual American sailors manning the 5-inch guns with VT rounds became legends in their task forces. On USS Hugh W. Hadley during the May 11th attack, her crews claimed 17 confirmed kamikaze kills using proximity-fused ammunition, employing continuous fire to lead attackers through a wall of VT, able to fire roughly 15 rounds per minute. Each shell carried its own electronic brain, and in 152 Span Hadley's batteries knocked down multiple kamikazes in succession because even shots passing above or below maneuvering planes would detonate effectively. The tale of USS Aaron Ward during the May 3rd attacks highlights how the proximity fuse multiplied a ship's defensive power. When 40 kamikaze planes slammed toward the destroyer, her 5-inch mounts kept firing without stop for 52 minutes, and VT-equipped shells outright destroyed 6 attackers, while crippling 5 more so they fell into the sea. Commander William Saunders later said that, absent proximity fuses, his vessel would likely have been swamped within the first 10 minutes. The capacity to fire without painstaking range setting let Aaron Ward's batteries pivot quickly among threats, something impossible with time-set fuses. Those stories were repeated across the 10 major Kikasui strikes from April 6 to June 22, 1945. Japanese forces threw roughly 1,900 aircraft into coordinated kamikaze operations. US ships, largely armed with VT 5-inch rounds, brought down hundreds before they reached their objectives. Operations researchers found that vessels using proximity-fused ammunition were about 3 times likelier to survive heavy suicide attacks than ships relying mainly on traditional rounds. What might have been a devastating new tactic for Japan instead became an expensive but containable menace because of the fuse. American crews refined tactics around VT rounds, learning that firing patterns which produced overlapping clouds of fragments were especially lethal. Ships synchronized their barrages to form virtual VT boxes that incoming kamikazes had to fly through. Japan's counter-SADC at dawn, using multiple approach axes, or mixing conventional and suicide planes, could not overcome the basic edge of shells that detonated at the right moment. The production numbers underpinned that advantage. By June 1945, U.S. industry was turning out about 70,000 proximity fuses every day. Over the whole war, more than 22 million were made at a 1940s cost above $1 billion, roughly $15 billion in today's dollars. Crosley Corporation alone employed some 10,000 workers across 3 shifts, 7 days a week, and unit costs plunged from about $732 in 1942 to roughly $18 by 1945 thanks to mass production gains. Navy studies concluded this enormous investment saved dozens of ships during the Okinawa campaign. Japan's industrial base, shredded by strategic bombing and resource shortages, could not match that output. Although Japanese scientists grasped the fuse concept, some intelligence about Allied special munitions via German reports carried by submarine they lacked the manufacturing infrastructure to design and mass-produce such complex devices. Even the vacuum tube technology demanded precision that Japan's wartime factories couldn't deliver. Japanese radar development, essential to understanding and applying proximity fuse ideas, lagged far behind American systems. The Type 22, their best naval radar, used wavelengths that made the kind of miniaturization required for proximity fuses impractical even if production capacity had existed. The fuse's battlefield success forced changes in Japanese tactics during the campaign's closing months. By May 1945, kamikaze pilots were ordered to start from high altitude and then dive straight down, hoping altitude would reduce exposure to VT anti-aircraft rounds. That tactic cut some losses during the approach but made accurate hits much harder. Ships could maneuver out of the dive path and radars had more time to pick up attackers, so the adjustment backfired strategically. Admiral Richmond K. Turner, who commanded the amphibious forces at Okinawa, credited proximity fuses with enabling the invasion, telling the Navy's leadership that without VT rounds, losses from suicide strikes would have been unbearable and that Japanese special tactics might have altered the Pacific War, absent U.S. superiority in air defenses. Admiral Mark Mitcher's flagship USS Bunker Hill survived a savage kamikaze on May 11th, in part because VT fire knocked down 3 other attackers that might otherwise have finished her. Admiral Arleigh Burke later recalled that, when he joined Mitcher's staff, virtually all 5-inch ammunition for the fast carrier task forces carried VT fuses, and those fuses brought down enemy planes by the dozens. The proximity fuse's effects went beyond killed aircraft and saved hulls. It reshaped the cost-benefit logic that had sustained kamikaze doctrine. Japanese assumptions that sacrificing pilots guaranteed ship kills no longer held when hit rates fell below roughly 20% under VT defenses. That decline made the exchange unsustainable even within the brutal calculus of suicide warfare. And many young pilots, some university students, pressed into special attack units began to realize their deaths might accomplish little. Post-war letters show a growing awareness among kamikaze volunteers that American defenses had outpaced what their leaders had promised. Early successes by leaders like Lieutenant Yuki, whose unit scored heavy strikes against escort carriers when proximity fuses made up only a quarter of anti-aircraft ammunition, stood in stark contrast to Okinawa. There, successors faced a different reality. Lieutenant Commander Goro Nonaka's Thunder God unit, equipped with piloted Oka rockets, lost an entire squadron on March 21, 1945, before a single Oka could be released. Radar-directed U.S. fighters shot down all 18 Betty Mother planes, and even a breakthrough would have met an impenetrable wall of VT fire. The fuse's sophistication reflected advances far beyond simple manufacturing. It combined breakthroughs in electronics, materials, science, and systems integration that Japan could not match. Miniaturized vacuum tubes produced by firms like Sylvania and Raytheon used special glass that survived extreme shock. The firing-activated battery chemistry stayed inert for months and then powered up instantly under acceleration. Radio frequencies were chosen to limit interference while maximizing detection range. Each featured the product of years of concentrated research backed by vast resources. By contrast, Japanese anti-aircraft armament remained comparatively primitive. The Type 98 100mm AA gun, their best heavy anti-aircraft piece, still depended on mechanical time fuses set by hand. Ships at Okinawa, including the mighty battleship Yamato, on her final sortie, carried AA ammunition that was essentially what the U.S. had used at Pearl Harbor. When Yamato encountered more than 300 American planes on April 7, 1945, her 162 anti-aircraft guns expended thousands of rounds but shot down fewer than 10 attackers. The U.S. lost only about 10 aircraft while sinking the world's largest battleship, a dramatic illustration of the technological gap. The proximity fuse opened tactical options that conventional shells could not, prompting destroyer crews to devise the VT umbrella. Pre-arranged barrages of proximity-fused rounds, fired above friendly ships, so that shells would burst at predetermined distances and form a protective dome of flying fragments that attacking planes had to pierce. This approach was especially useful against piloted Oka rocket bombs, whose speed made them hard to track with ordinary fire control, but left them vulnerable to the fragment barriers produced by VT patterns. During the Okinawa campaign from April 1 to June 22, 1945, the U.S. Navy fired roughly 150,000 proximity-fused 5-inch rounds. Although VT rounds made up about 45% of heavy anti-aircraft ammunition, they accounted for most of the confirmed long-range kamikaze kills, while time-fused rounds, about 55% of use, were largely effective only at close range. Mathematically, proximity-fused shells were roughly 3 to 4 times as lethal against suicide attackers as conventional ammunition, and the human cost made that difference stark. Ships that ran out of VT rounds and reverted to time fuses suffered much heavier casualties. The destroyer, USS Drexler, having exhausted its VT rounds, was sunk in under a minute on May 28 by 2 kamikazes that likely would have been destroyed by proximity fire, leaving 158 dead, more than many destroyers lost in entire campaigns. Even senior officers experienced the threat firsthand. Admiral Raymond, after his flagship Indianapolis was hit in March and he moved to New Mexico, which was also attacked in May, noted that the suicide plane was a formidable weapon, but acknowledged that VT fuses had saved countless ships and lives and were the difference between tolerable and unbearable losses. Planners preparing for Operation Downfall factored the fuse into their calculations. Intelligence suggested Japan had reserved some 10,000 aircraft for special attack strikes against an invasion armada. Yet us strategists, confident in VT effectiveness, planned to meet defensive needs. Production was due to ramp to 100,000 fuses per day by September 1945, and new Mark 53 and Mark 58 variants were entering mass manufacture, so an invasion fleet would carry more than 1 million proximity-fused rounds. The atomic bombings of Hiroshima and Nagasaki ended the war before that ultimate trial. But Japanese post-war assessments showed the electronic shells had weighed heavily in surrender thinking. Admiral Samu Toyota testified that Homeland Defense kamikaze attacks would have succeeded at under 10% against proximity-fused defenses, a failure rate that rendered the tactic militarily pointless. The program that produced the VT fuse mobilized some 112 additional firms around core contractors, forming an industrial network capable of building the era's most advanced military electronics. British scientists who first proposed the idea in 1940 recognized that American industrial scale and precision made possible what they had judged impossible: surviving gun launch stresses in vacuum tubes. The fuse's success seeded decades of weapons development. The notion of munitions with onboard sensing and decision-making became central to U.S. doctrine. Modern anti-aircraft missiles use proximity triggering, descended from the VT concept. And today's shipboard close-in weapon systems trace their lineage to the defensive methods refined against Kamikaze. Japanese veterans and commanders later expressed amazement. Commander Tadashi Nakajima admitted the fuse exceeded imagination. Pilots reported shells detonating exactly where they flew, as if guided by invisible hands, and survivors like Captain Akiro Tta reflected that the electronic fuse demolished the premise That spiritual resolve could overcome material inferiority. Beyond tactics, the proximity fuse contrasted to wartime worldviews, an American investment in preserving lives through superior technology versus a Japanese willingness to use human life itself as a weapon. By making kamikaze attacks survivable for the fleet, the VT fuse undercut the cruel logic behind suicide missions and came to symbolize not only technical dominance but a moral argument about how modern wars are fought. The crash program that created the VT fuse also set a template for later U.S. achievements from spaceflight to computing by demonstrating how universities, industry, and the military could collaborate under pressure to produce millions of sophisticated electronic devices. Johns Hopkins Applied Physics Laboratory, where much of the work was centered, evolved into a long-lasting hub of military innovation, and Dr. Merle Tuve, who led the effort, later reflected on the program's historic impact. Making weapons more effective saved lives. Every kamikaze brought down by a proximity VT fuse meant an American sailor returning home, a payoff that justified the effort and expense. The program's success proved the American belief in solving military problems with science, a mindset that would shape Cold War defense policy. For Japan, the inability of suicide attacks to penetrate VT-defended zones shattered notions of spiritual superiority. Young pilots sent into futile runs against curtains of proximity explosions became symbols, not of noble martyrdom but of leadership that had failed to grasp technological reality. Modern Japan's focus on innovation partly sprang from the harsh lesson of 1945, when electronic fuses outperformed human pilots with clinical precision. The numbers made the case. Proximity-fused rounds needed about 310 shells per kill versus roughly 1,162 for time-fused rounds, a level of efficiency that saved ships, preserved lives, and helped deliver strategic victory. Each working VT fuse meant another sailor who survived, another ship that could fight on, and further proof that engineering could decide modern battles. Hundreds of suicide aircraft destroyed before reaching their objectives translated into thousands of American casualties avoided, dozens of hulls saved, and vindication of the billion-dollar investment in electronic ordnance. The clash between technology and fatalism reached its peak off Okinawa, where radar-guided fighters, proximity-fused anti-aircraft shells, and advanced damage control beat back intentional suicide attacks. The young kamikaze pilots, brave but sacrificed to a doomed tactic, flew into an electronic killing field their commanders had not anticipated. Their strikes produced horrific tactical damage but failed to impose the strategic cost needed to make invasion unaffordable. The VT fuse converted a potentially catastrophic tactic into a contained threat. Secretary of the Navy, James Forstall, summed it up. The proximity fuse blazed the trail to Japan, and without its protection, the westward advance would have been slower and far more costly in men and ships. Commanders throughout the Pacific echoed that assessment, recognizing that electronic superiority had overcome suicidal devotion. The final tally was sobering but decisive. During Okinawa kamikaze attacks, sank 36 American ships and damaged 368 others, grievous losses, yet still reflecting the survival of the vast majority of vessels under attack, an outcome made possible by proximity fuses. The 497 American sailors killed by kamikazes at Okinawa, while constituting the Navy's bloodiest battle, were fewer than projections had predicted absent VT technology. Japanese losses were absolute, roughly 1,900. Aircraft and pilots expended during the 10 Kaikasui operations, plus hundreds more in improvised suicide efforts, produced tactical effects that fell well short of strategic goals. The proximity fuse's triumph over kamikaze raids proved that in modern warfare, technological superiority can defeat advantages in numbers, determination, or willingness to die. American crews at 5-inch batteries armed with VT rounds held the decisive edge over pilots sealed into one-way missions. The tiny radio transmitter in each shell's nose embodied industrial capacity, scientific knowledge, and organizational skill that no amount of martial spirit could match. When electronic fuses met human pilots above Okinawa, the outcome had already been shaped by factories in Cincinnati, laboratories in Maryland, and an American conviction that technology could save lives while securing victory. The arithmetic was stark. A proximity fuse weighing under 5 pounds, containing about 130 components, built for roughly $18 by 1945 and functioning for less than 30 seconds, could destroy a kamikaze and its pilot years of training, tons of aluminum and steel, and a life lost forever, multiplied across thousands of encounters in the Pacific. That equation translated into strategic success through technological superiority, validating the U.S. approach to 20th century warfare. Invest in innovation, trust mass production, and believe that better equipment can overcome fanatical resolve. For Japan, the kamikaze's failure against proximity-fused defenses meant not only military defeat but a repudiation of the idea that spirit could prevail over material disadvantage. The electronic fuse had neutralized the divine wind, showing that in the crucible of modern war, advanced technology would outmatch human sacrifice. Okinawa illustrated a broader lesson about industrialized conflict, nations able to marshal scientific knowledge, manufacturing capability, and organizational expertise to field superior defensive systems, held decisive advantages over those relying chiefly on courage. The proximity fuse embodied America's strengths: inventive engineering, scalable production, and systematic problem-solving applied to battlefield challenges, and its victory over the Kamikaze demonstrated that success in modern war belongs to those